So we're diving into batteries today.
Batteries.
Yeah, but not just any batteries. We're talking about batteries that could last for thousands of years.
Thousands of years.
Mm.
That's pretty wild.
It is wild. We're talking about a technology that could revolutionize pretty much everything. Think medical devices, space exploration, even how we think about energy itself.
Yeah, I've heard a little bit about this forever battery concept. It's definitely caught my attention.
It's caught everyone's attention, and for good reason. I mean, imagine never having to replace a battery again.
A pretty tantalizing idea.
It is. So we've got some research excerpts here about this carbon-14 diamond battery, and honestly, even just skimming through them, my mind was blown.
Yeah, I can imagine. There's a lot to unpack there.
There is. So let's start with the basics.
Yeah.
What exactly is a carbon-14 diamond battery?
Okay, well, first you need to understand a bit about radioactive decay. It's basically the process of an unstable atom losing energy by emitting radiation.
Right, like uranium or plutonium, that kind of thing.
Exactly. And carbon-14 is a naturally occurring radioactive isotope of carbon.
Okay, so it's carbon, but it's kind of unstable.
Right, and it's this decay process that powers the diamond battery.
So we're talking about harnessing the power of radioactivity.
In a very controlled and safe way, yes. The carbon-14 is encased within a diamond lattice, and as it decays, it releases high-energy electrons.
Okay, so the diamond is like a container for the carbon-14.
It's more than just a container. The diamond structure itself acts as a semiconductor, capturing those electrons and converting that energy into usable electricity.
So the diamond is actually part of the energy generation process. That's pretty clever.
It is, and it's this combination of the carbon-14's decay and the diamond's properties that gives the battery its incredible lifespan.
Okay, so let's talk about that lifespan. You said thousands of years, right? How is that even possible?
Well, it all comes down to the half-life of carbon-14,
right,
which is around 5,700 years.
Half-life. Remind me what that means again.
Sure. A half-life is the time it takes for half of the radioactive material to decay. So even after 5,700 years, you'd still have half of the original carbon-14 left generating power.
So it's not literally forever, but in human terms, it might as well be.
Pretty much.
Okay, so we've got this battery that could potentially last for thousands of years. What are we going to do with it? What are the potential applications?
Well, the research highlights a lot of exciting possibilities. One of the most promising areas is medical devices.
Oh, right. I read something about pacemakers and hearing aids, things like that.
Exactly. Imagine medical implants that never need their batteries replaced. It would be a game changer for people who rely on those devices.
Absolutely no more surgeries, no more disruptions to their lives. That's incredible.
And it goes beyond medical devices. The research also talks about applications in extreme environments, like space exploration and deep-sea exploration.
Right, because in those situations, it's not exactly easy to just swap out a battery.
Exactly. So having a power source that could last for decades or even centuries would be invaluable.
It's like something straight out of science fiction. A battery that could power a spacecraft on a mission to another planet.
It is pretty mind-blowing.
Okay, so we've covered the basics of what a carbon-14 diamond battery is and some of the potential applications, but I'm curious to dig a little deeper into the science. How does it actually work on a technical level? What's happening inside that diamond structure?
Sure. Well, diamonds are known for being incredibly strong and stable, but they also have some unique electrical properties. They can act as both insulators and semiconductors, which is key for this application.
Okay, so remind me what a semiconductor is again.
A semiconductor is basically a material that can conduct electricity under certain conditions, but not others. It's like a gate that can be opened or closed to control the flow of electricity.
Got it. So how does that play into the diamond battery?
Well, the carbon-14 is embedded within the diamond lattice. And as it decays, those high-energy electrons are released, but instead of escaping, they're captured by the diamond structure.
So the diamond acts like a net, trapping those electrons.
Exactly. And because diamonds are so good at conducting heat, they can handle the heat generated by the radioactive decay without any problems.
So it's like a perfectly designed system. The carbon-14 provides the energy the diamond captures and converts it, and the whole thing is incredibly stable and long-lasting.
It is, and it's a testament to the ingenuity of the scientists and engineers who developed this technology.
Speaking of which, this whole thing sounds like a pretty big collaborative effort. Who's behind this research?
The research mentions a collaboration between the UK Atomic Energy Authority and the University of Bristol.
Ah, that makes sense. The Atomic Energy Authority would have the expertise in handling radioactive materials, and the University of Bristol is known for their materials science research.
Exactly. It's a great example of how interdisciplinary collaboration can lead to groundbreaking discoveries.
It really is. And it sounds like the scientists involved are pretty excited about the potential of this technology.
Oh yeah, the research quotes them as saying things like absolutely game-changing and a world first.
Wait a minute, they actually have a working prototype. I thought this was all still theoretical.
It is early days, but they've successfully created a device where the radioisotope is integrated within the diamond and is generating power.
Wow, that's incredible. So they've proven that the concept actually works.
They have. They even included a picture of the prototype next to a standard lithium battery to show the size difference.
I bet that's a pretty striking image.
It is. The diamond battery is tiny compared to the lithium battery, which really highlights the potential for miniaturization with this technology.
Okay, so we've talked about how it works and some of the potential applications, but I have to ask, what about safety? Are there any concerns about using radioactive material in this way?
That's a valid question, and one that the researchers have addressed. The amount of carbon-14 used in these batteries is incredibly small, far less than what you'd find in a smoke detector.
So it's not like we're all going to be walking around with tiny nuclear reactors in our pockets.
No, not at all. And the carbon-14 is completely encased within the diamond lattice, which acts as an incredibly strong and stable barrier.
So it's safely contained.
Yes. The research specifically mentions the diamond as a safe enclosure for the radioactive material.
That's reassuring to hear. Okay, so it seems like they've taken the necessary precautions to ensure safety. But what about the practical challenges? Is this something that can be scaled up for mass production?
That's where things get a bit more complicated. The technology is still in its early stages, and the power output of these batteries is currently quite low.
So you're saying it's not quite ready to power our smartphones just yet?
Not yet, but the research outlines a plan for the next decade, focused on upscaling production and improving power performance.
So they're actively working on making it a viable option for a wider range of applications.
They are. And given the potential benefits, I think it's worth the effort.
I agree. It's not every day that a technology comes along that could potentially revolutionize the way we think about energy. It's pretty exciting stuff.
It is. And it's just the beginning. I think we're going to see a lot of innovation and development in this area in the years to come.
I can't wait to see where it all goes. I mean, we've talked about the how and the why, but what really stands out to you as the most fascinating aspect of this diamond battery technology?
That's a good question. I think what really captivates me is how it challenges our assumptions about energy. We're so used to thinking about batteries as having a limited lifespan. This technology forces us to rethink that entire paradigm.
Yeah, you're right. It's not just about a new type of battery. It's about a completely different way of thinking about energy. And that's where things get really interesting.
Yeah, it really makes you think, doesn't it?
Yeah.
What would a world without the limitations of batteries even look like?
It's hard to even imagine.
I know. And the research touches on that. They talk about this technology impacting everything from how we design devices to how we think about time and consumption.
It's pretty profound when you think about it.
It is. And one of the things they emphasize is the sustainability aspect.
Oh, right. The environmental impact. Yeah. We all know about the problems with traditional batteries, especially lithium-ion batteries. They're not exactly eco-friendly.
Definitely not. They create a lot of waste, and they rely on finite resources.
Exactly. So could diamond batteries be a solution to that?
They could potentially. I mean, imagine a future where we eliminate the need to dispose of billions of batteries every year. That would be a huge win for the environment.
It would. But are we just trading one problem for another? Are there any potential downsides to this forever power concept?
That's a good question, and one that we should definitely consider. The research doesn't go into a lot of detail about potential downsides, but there are definitely some things to think about.
Like what?
Well, even though these batteries could last for thousands of years, they won't last forever.
Sure.
So we still need to figure out how to dispose of them responsibly at the end of their very long life cycle.
So it's not a completely waste-free solution.
Not exactly. And then there are the economic considerations. How much will it cost to produce these diamond batteries on a large scale? Will they be accessible to everyone, or will they be limited to certain industries or applications?
Those are all important factors.
They are. And it's important to have these conversations now before this technology becomes widespread.
I agree. We need to think about the long-term implications, both positive and negative.
Exactly.
Yeah.
It's not just about the wow factor of a forever battery. It's about making sure that this technology is used responsibly and sustainably.
Okay, so it seems like there's a lot more to consider than just the technological aspects of this.
Uh,
We need to think about the environmental impact, the economic feasibility, the ethical implications. It's a pretty complex issue.
it is, and it's one that deserves careful consideration.
Definitely. So where do we go from here? What are the next steps in the development of this technology?
Well, the research outlines a plan for the next decade focused on two main goals: upscaling production and improving power performance.
Okay, so they're working on making it more practical and affordable.
Exactly. They want to make diamond batteries a viable option for a wider range of applications.
That makes sense. But how are they planning to do that? I mean, what are the specific challenges they need to overcome?
One of the biggest challenges is the production process. Right now, creating these diamond batteries is very specialized and expensive.
So they need to find a way to mass produce them.
Right. They need to make the process more efficient and cost-effective.
Kind of like what happened with solar panels, right? They were initially very expensive, but as the technology improved and production scaled up, the price came down.
Exactly. That's the hope with diamond batteries as well.
Okay, so that's the production side. What about the power performance? You mentioned that they're working on improving that as well.
Yes, right now the power output of these batteries is still quite low. It's enough for small devices like sensors, but not for things like smartphones or electric cars.
So they need to find a way to boost the power output without making the batteries too big or too expensive.
Right. It's a delicate balancing act.
I can imagine. So how are they approaching that challenge?
They're looking at a few different approaches. One is using nanodiamonds.
Nanodiamonds? What are those?
They're basically tiny diamonds with a much larger surface area compared to their volume.
So they're like miniature diamonds with more surface area to work with.
Exactly. And this increased surface area could potentially allow for more efficient energy capture and generation.
Okay, that makes sense.
They're also exploring different radioisotopes with higher energy densities than carbon-14.
So they're not just sticking with carbon-14, they're looking at other options as well.
Right. They're exploring all avenues to find the most effective way to create these forever batteries.
It's pretty amazing stuff.
It is. And it's exciting to think about the potential impact this technology could have on our world.
It is. I mean, if they can overcome these challenges, we could be looking at a future where batteries are no longer a limiting factor in our technological development.
Exactly. It's a pretty tantalizing prospect.
It is. So as we wrap up this part of our deep dive, I want to ask you this. If this technology does take off, how do you think it will impact our society as a whole?
That's a big question.
It is, but it's an important one to think about.
I agree. I think the impact would be profound. Imagine a world where we no longer rely on fossil fuels for energy, where our devices are powered by tiny, long-lasting batteries that never need replacing. It would be a fundamental shift in the way we live.
We were talking about a complete paradigm shift.
Yes, it would affect everything from transportation and infrastructure to communication and healthcare.
Wow. It's almost overwhelming to think about.
It is, but it's also incredibly exciting. This technology has the potential to solve some of the biggest challenges facing humanity and to create a more sustainable and equitable future for all of us.
I like the way you think. I think you're right. This technology really does have the potential to change the world.
It does. And it's not just about the practical applications, it's about what it represents.
What do you mean?
Well, it represents a shift in our thinking, a move away from the limitations of the past towards a more sustainable and abundant future.
I like that. It's a symbol of hope.
It is. And it's a reminder that we're capable of incredible things when we put our minds to it.
Absolutely. So as we wrap up this deep dive into diamond battery technology, I want to leave our listeners with a few final thoughts.
Oh.
First of all, this technology is still in its early stages. There are challenges to overcome and a lot of research and development still to be done.
Right. It's not going to happen overnight.
But the potential is there. And I think it's important to be aware of that, to see the possibilities and to support the development of this technology.
I agree. We need to be informed and engaged.
We do. And we need to think critically about the implications of this technology, both positive and negative.
Definitely. It's not a magic bullet.
Yeah.
It's a tool. And like any tool, it can be used for good or for ill.
That's a good point. It's up to us to ensure that this technology is used responsibly and ethically.
Absolutely. And that starts with education and dialogue.
Exactly. So we encourage you, our listener, to learn more about diamond battery technology, to ask questions, to share your thoughts and concerns.
Be part of the conversation.
Yes, because the future is not something that just happens to us. It's something we create together.
And this technology, it has the potential to be a part of a brighter, more sustainable future.
It does. So let's make it happen. Until next time, stay curious, stay informed, and keep exploring the frontiers of science and technology.
Please like this video and subscribe to our channel. For more detail you can visit our blog website www.evergreentechtips.com.